Hello folks! Over this past week I set aside some time for a nice Balsa aircraft build. This video will summarize my process and methods. I begin by getting my airfoil template from the wonderful website airfoiltools.com. In this case, a NASA 0012 because I want a more sleek and speedy wing. I then make a balsa template and use it to mark out 20 ribs on 1/8 inch thick balsa. Here I've cut them out. I then use the template to mark 19 leading edge ribs on 1/8 inch thick balsa. This will create a stronger and more aerodynamic leading edge. Here I've cut them out. I then made this 1/2 inch square balsa spar from 2 1/4 inch thick layers because that's all I had, so it's not perfectly straight, but it'll do. Here I'm lining up all the leading edge ribs and closing off the spar aperture of each with a balsa cross member. And here I've aligned all the ribs and sanded them flush to each other. These pre-cut ailerons came from a box of random unwanted balsa that a friend recently gave me. These pre-cut leading edges came from the same source. Here I fitted everything together and lightly tacked the leading edges into place. Here I've added top and bottom layers of 1/16 inch balsa to form the trailing edge. I then curved a piece of 1/32 inch balsa sheet around the leading edge to create a very smooth contour between the solid spars and the ribs. Here I've attached the ailerons with a hinge made from Misaki tissue strengthened with wood glue. And it was at that point that I decided I wanted flaps. So I made these flaps by extending a couple pieces of that pre-cut aileron material. Here they are attached with that same Misaki tissue hinge. Such a hinge may seem unfitting, but it's actually impressively resilient. I then added all 4 wing servos, 9-gram SG90s, and cleaned up the wiring as shown here. Here I've covered the wing with translucent red park light film. I then made this pair of tapering spars for the wingtips from very dense balsa. These tip ribs are NASA 2412 airfoils made from 3/16 inch balsa. These ribs will compose the joints between wing and wingtip, hence these are strong 1/4 inch thick balsa. Here I've attached the ribs to the spars, and here I've finished off the wingtips with leading and trailing edges sanded flush to the ribs. I then covered the wingtips with opaque blue ultracoat light film and attached them to the main wing. I then hooked up the ailerons using control horns from an old E-Flight ARF aircraft. It was then time for the tail surfaces. This is the horizontal stabilizer template, cut from 2 pieces of A4 paper. I traced out the shape on 1/4 inch balsa, cut the blank, and sanded it to an airfoil as shown. Now you may notice this airfoil appears upside down with all the curvature being on the bottom. A quick explanation for that. To achieve pitch stability, we always want an offset between the incidence of the wing and that of the stabilizer, causing the aircraft to nose up. We counter that with a forward CG, and the distance between CP and CG gives us our décalage, or margin of stability. Now, you're used to seeing gliders on this channel, and for gliders we set the condition that both incidences be positive. Basically, that's efficient because both lifting surfaces are then making positive lift all the time, and besides, a glider's negative glide slope will give level surfaces some relative incidence, so putting lifting surfaces at negative incidence would just kill the efficiency. But our powered aircraft doesn't have those constraints. We can get the offset by setting the stabilizer at a negative incidence. That way the wing doesn't have to be at an impractically high incidence. Besides, we have lots of power, so the decrease in lift-to-drag ratio caused by a non-lifting tail can be tolerated. So we shoot for a negative stabilizer incidence and a positive wing incidence. But if we're putting the stabilizer at a negative incidence, we want an airfoil that flies efficiently at that incidence. A normal airfoil won't do because it's designed for flying at positive incidence, but if we flip it over, well, that'll do just perfectly. Well, then I finished up the stabilizer, giving it a packing tape hinge strengthened with a thin coat of epoxy resin. These 3 parts are to compose the vertical stabilizer, and here I've glued them together with epoxy. I then sanded the part down to an airfoil and moved on to the fuselage. Here I've marked the fuselage shape on 2 pieces of 3/32 inch balsa. The upper tail taper was based on the golden ratio, and the bottom taper was based upon the upper taper, some pointless mathematical shenanigans that nonetheless deserve a mention. I then cut out both fuselage panels. Here the fuselage bottom plate is marked out on 1/8 inch thick balsa with marks for the empennage formers. Here the part is cut out. These are the blank shapes of the fuselage formers. I'll trim them down to the right height and add pushrod holes once they're glued into place. I then assembled the bottom plate and 1 side plate, adding a doubler onto the bottom plate under the wing location. The other side was then added. The formers were then added, trimmed flush with the sides, and pushrod holes were drilled. This motor mount was made from 2 cross-grain 1/8 inch thick layers of basswood. Here is the power system used. The motor was then screwed onto the mount. The motor mount was then attached to the nose with epoxy. 2 push rods were then made. A layer of resin-cured carbon was sandwiched between 2 layers of balsa wood, and 1/16 inch music wire ends were inserted while the resin was wet, encasing them in the carbon, a very strong push rod. The elevator is then hooked up to an HD Power HD1600A servo. I really do love those little HD Power servos. The control horn was made from 16th inch aluminum. Here, the top of the tail section was cut from 3/32 inch balsa. It was then glued into place with some intentional overhang that could later be sanded smooth. The rudder was then hooked up to another nice HD Power HD1600A servo, again with a 1/16 inch thick aluminum control horn. This set of landing gear came from an old flight test aircraft I had. I attached it with copious fiberglass reinforcement. I then attached the wing to the fuselage with the simple and effectively modular rubber band strap method, and I hooked up all the mechanisms. I then set mixes from flaps to ailerons and from ailerons to rudder. The aircraft was then ready for its maiden flight. Now, I have carried out that maiden flight, and it was a wonderfully successful endeavor, but for fear of drawing this video far beyond its optimal duration, I shall save the whole matter of maiden flights for next week's production. So, stay tuned, and as always, thanks for watching!